which way is the electric field from the positive plate? Right?
Correct.
From the negative plate, what's the direction of the electric field here because of the negative plate? And over here because of the negative plate? Because it goes towards the negative, away from positive. Because the electric field does not depend, the magnitude of the electric field from the plate does not depend upon how far you are. Out here, what's my total electric field?
Zero?
Yes, out here.
Zero.
And in here?
Zero.
No. They're going in the same direction in
Oh,
here.
I see that.
Twice as much. Just twice as whatever the charge of those are.
Twice that. So in the middle here, my electric field strength is sigma over epsilon sub naught. Out here, it is 0. Out here, it is 0. If I have two plates that are opposite charged of each other like that, that is not called a capacitor. It's used for storing energy. You can store up a certain amount, and then you can, and then there are mechanisms so that you discharge it very quickly. So if you need a lot of current in a very short amount of time, such as in a flash in a camera, you store up a lot of charge, and then when you click the button with the flash to engage, it basically connects the two, and you get this huge rush of current in a very flat, bright light. And also, you can take a disposable camera with a flash on it and turn it into a taser. By the same thing, you charge up the capacitor, and then you touch it to somebody. If you do experiment on yourself on this, don't film it and put it on YouTube, please. Don't. If I have something in between that is an insulator, because if I put something in between, so if I fill this space up with a conductor, the charge will just run right through it. But if I put something in between that is an insulator, for example, paper, then this thing that's in the middle, that is an insulator, is called a dielectric. We will do a lab at some point where we will use various dielectrics, which are insulators. We'll use various insulators in between and try to figure out what is the dielectric constant. In other words, what is the relative permittivity of those pieces of whatever we stick in between. Yeah, so dielectric constant is just the actual permittivity of the material divided by permittivity of free space. So relative permittivity. A lot of vocabulary through there at the end. I made the mistake, as I think a number of people do, so I'm going to say in company, of you're running out of time, so speak faster. Well, the good news is that plenty of time to cover all the material here, material for 152, so there's not the panic rush at the end of how many more chapters can we get in with 1 week to go?
Yeah, I believe we covered at least a chapter and a half worth of material on the last Monday of class before our final on Wednesday. Like 2 pages of our final exam involved with that material.
And
Crazy.
is there something wrong with that?
No, it's
I'm
great.
going to deprive
So
you of
great.
that experience this semester.
So good.
That was in this class, like last semester, you mean?
Yeah.
Wait, there was a bunch of stuff covered near the end there.
That's okay.
Yeah, it worked out.
Really fun.
Yeah, your class asked a lot of questions, so that
Yes.
I apologize.
No,
Retrospect.
absolutely not.
No,
I would rather deal with the questions.
They're
And,
needed for clarification.
I mean, what's the worst that happened is that we covered a month worth of material in a day. Anyway, I hope you have all a very good weekend. I will say that right now it seems like